What's up, guys? I'm back here with another video, and I've noticed, I think everyone and their dog has made a how to learn machine learning video. However, I've noticed a lot of these videos on how to learn machine learning, they really assume a lot of technical knowledge and a lot of knowing how to code that I don't necessarily think a lot of people starting out have. Um, I came to this realization because I was recently tutoring someone, and she was taking a machine learning course with Udemy, and she had some code that she was asking for help with, and she was doing a train test split, and she followed along with the code, and she didn't. I'm not saying this to belittle her at all. Like, I wouldn't expect anyone just starting out, have never coded before, to be able to understand this, do it well, but she really struggled to even understand the concept. Like, there's this scikit-learn train test split, which is a fairly simple concept if you're a data science person. But I was trying to explain, I tried to explain it in several different ways, and it was really difficult to explain, like, how does it work and what is the purpose of the train test split, and like does the code look the way that it does. And I just realized, like, I was thinking, like, why is this so hard? And then I'm thinking, like, there's, like, to even explain how a train test split works. I mean, granted, I'm probably not the best at explaining things, but I kind of find it really hard to not use some like tech jargon, basically. So when I'm thinking, like, she's going right into machine learning, but it's kind of like needs to be some more like advice on what kind of like how to learn machine learning before you start machine learning, like pre-machine learning kind of. I'm not going to say names, but there's this YouTuber that used to be like really big in the data science space, and he has these like how to learn data science, how to learn machine learning tutorials, and they just dive right into the machine learning, and it's like it doesn't even explain how the code even works. And he'll sometimes say, like, okay, we're indexing here or having a for loop, but like that doesn't even make sense to someone that's never coded before. So like I said, this may sound a bit like a broken record, but the first thing to start off with machine learning is the Python basics. So really, like, I would just say that a couple of things that are really important to watch out for when you're taking the course. And like I said, most of these courses, they'll pretty much get you where you need to be. Some people may need extra help, may need tutoring or something, but generally, I think like Udacity, Udemy, these kind of like, education platforms do have like the courses, cheap little $10 courses that can get you there. But the things to really pay attention to is data types, because data types they're really important for anything, especially machine learning, because if they're not the right data type, it won't even work. Indexing, which is a way to, like, if there's like a list of numbers or letters or numbers or characters or something, you can select certain numbers and characters out of like a list of them, or others, basically, just in a simpler terms, out of a list. It's like selecting elements out of a list. Math operations, just like addition, subtraction, just your basic math, but like in the coding it, and then like I said, I personally took the Udacity course. Is how I learned Python in about 3 weeks. So that I could vouch for that one. I'm sure Udemy has a very similar thing going on in terms of courses. The next step would be to learn descriptive statistics. So you probably already know these, like, as concepts. Mean, median, standard deviation, mode, and square root is what I have listed here in this PowerPoint. But they're off, a lot of them, most of them can be calculated using NumPy. And they're basically, learning how to code this is important because a lot of data analysis can be stemmed from calculating averages and medians and standard deviations and square roots. So yeah. So that's why I think that's the next important thing to do. Like learning how to just, calculate the square root, like have a, be able to like generate numbers and then calculate their square roots or something would be really good thing to know how to do. The next after that, once you've kind of gotten comfortable with like doing some math operations and selecting elements from the list or other data types, and changing data types as well, like turning numbers into characters, for example, or just to name an example. But once you're comfortable with that, you can start working with pandas. And pandas, I've got some functions listed: dot lock, ilock, apply, drop off, fill off, value counts, drop, and data frame. These functions, you learn these functions. They're probably the core of Python, or sorry, the core of pandas. I use them more than any other pandas functions, I'd say. And this way, when you have data sets, you're able to kind of manipulate the data sets and do certain things to the data that will make it be able to have machine learning models trained on them, put the data set in a position to actually be able to give you better insights and be more analyzable, I guess you could say. So the next thing, these next couple concepts, in theory, you could skip them and just go straight into machine learning. Depending on like if you're like super serious, like that's what you're here for, that's why you're learning to code, you might want to just play around with it a little bit just to get your feet wet. But it's kind of optional. If you could skip this, but you definitely want to come back to it. And this is like really important in terms of thinking like a data scientist, which is a common thing or common goal of people that learn machine learning. So hypothesis testing is really important. So in our example, let's say that we have a hypothesis that boys are taller than girls on average. So what we're going to do is we're going to take a bunch of samples of boys and girls of their heights, take a bunch of samples, and we're going to get, like, each sample, we're going to get the average height from each sample for all the boys and do it for all the girls. And then we're going to, like I said, I'm explaining at a very high level concept. We're going to analyze the differences between the heights, and then we're going to say that we're going to have a p-value at the end, and the p-value says basically that assuming, so okay, let me backtrack a little bit. So you have the in the hypothesis testing, you have the alternate hypothesis, which in this case is that boys are taller than girls. The null hypothesis is that boys and girls are the same height on average. So our p-value is given that the null hypothesis that boys and girls are the same height. This is the probability that our data set our data would come out looking the way that it does, given that boys and girls are the same height. So if boys are significantly taller than girls or whatever, the p-value is going to be really, really low, probably lower than 0.05, which means that there's a less than 5% chance that our data would look the way that it does, given that boys and girls are the same height. And typically that threshold of 0.05 or 5% is what's typically considered acceptable. So if your data is, if a p-value is less than that value, then it's safe to assume that the alternate hypothesis is true. So that was just a little kind of introductory to that. The next thing is correlation covariance. So basically with the hypothesis testing and this next thing, correlation and covariance, you're at a point where you're not doing machine learning. You're not making any predictions on data, but you are better understanding the data, which is something that is kind of neglected these days, I'll just say. And you don't want to, you want to focus on things that are neglected. So this stuff is not terribly complicated, but essentially you got correlation is basically like, how strongly there's a formula for it, but it's how strongly correlated are two variables, like I don't know, like the miles away from the beach that a house is in correlation to how much it costs. And then the other one is covariance, which is essentially kind of like how two variables interact with each other. So let's say like a common example is like as one stock price goes up, the other stock price goes down, and vice versa. So it's relatively similar to covariance. However, it's not, the correlation is more linear in the sense that where covariance is stuff that could just be like changing from day to day, like changes throughout time, let's say time dependent, whereas correlation is more often just like very directly like variable dependent, more linear, more of a slope, forms more of a slope. Which brings to the next topic, which is just coding the y equals mx plus b slope formula. This is pretty simple. They taught me this in 7th grade. At least my school system did. So it's not terribly complicated, but it's just knowing how to code it, knowing how to code and write a program that does it. And this is because this is the core concept for linear regression, which is a really popular machine learning model, often the first one people learn because it's the easiest to learn, and it's very explainable, which means like, okay, we can explain that, these variables go into predicting y because of the slope formula. It's very, very explainable. So it's a great place to start. And by doing this, you have a better understanding for how it works. The next step is gradient descent. So basically, gradient descent plus the slope formula is what creates linear regression. So gradient descent is used by almost all machine learning models, and it is used to inform the model of how it can make better decisions. So basically, you have, let's say you have a slope, or you have y equals mx plus b. So you've got a variable for m, which is the slope, like how strong is the slope? Is it very, is it like very much like in this picture right here? Or is it more just like, is it flat, or like how steep is the slope, essentially m? And then b is, where is the y-intercept? Is the y-intercept down here? Is it down here at the bottom? Is it up here? So it's and there's the correct, having the optimal value for the slope and the optimal value for the y-intercept, that creates the line of best fit, which is probably another familiar math concept. And that line of best fit, so gradient descent is the process of the computer trying to find the line of best fit. It tests out several different combinations for like the slope and the intercept until it gets to that sweet spot. So learning how to code this, when you can code this, you can actually say like you coded your own machine learning model. And that way in the future, when you start importing models, you can have an understanding of how it works. And unfortunately, this is a point where a lot of people kind of like this coding gradient descent from scratch is a pretty universally known concept, at least in my experience. But in terms of like data science curriculums and stuff, But a big problem I see, and I made this mistake myself, is like, okay, now I've coded this simple machine learning model, and then everything else after that is scikit-learn and import from scikit-learn. And the problem when you import from scikit-learn is these models, they're very like cookie cutter models in the sense that they're not really like, they don't really take into account the context of the situation where the model is being used, and that can lead to issues. So a lot of the most high performing models and use cases for data or use cases for machine learning, the model has often been customized. And to be able to build customized models, you have to have a very strong understanding of gradient descent and also the statistics concepts as well, which is something I'm really kind of weakness I'm trying to focus on, at least to some degree. And then finally, the train test split. Now, maybe I'm just biased putting this at the end because of how difficult the time I had explaining it. But really, until you've done all this other stuff, there's really no point in doing a train test split on your data set. There's really not. So then once you start working with scikit-learn, you can learn the scikit-learn train test split, where you split your data. So I would advise probably these Udacity machine learning courses are probably in whatnot, or Udacity, Udemy, etc., are probably like at this point here is when I would advise to actually take those courses if you want. I'd advise doing all of this other stuff beforehand. And unfortunately, there's not really much of a course. At least, well, there's Python courses. There's statistics courses. There's machine learning courses. There's just not quite anything that really puts it together the way that like is ideal. So that's why I've kind of mapped out this little learning path here. So if you find that along your journey you want to take a statistics course or a Python course or whatever, that's cool. It's just at the end of the day, this is all like coming to the central goal here of getting yourself ready for machine learning. So it's been, I think, about 15, 16 minutes, I think we're at. So anyway, I enjoyed making this. I hope you, oh yeah, and here's some photo credits for all the great photographers on Upsplash.com. But yeah, anyway, I've enjoyed making this, and I really hope that you guys can benefit from this, and also I do, at least for the time being, I'm still offering tutoring sessions. I don't mean to like throw any scarcity or anything, but I'm not really sure how much longer I'll be doing it. Maybe for the next 2 months, but like I said, I don't really know, but I know that now I'm still offering it. So anyway, yeah, I'll see you in the next video.